Good morning to all. So this is Dr. N. Ravisankar Reddy, working as a associate professor in Electrical and Electronics Engineering Department in G. Pullared Engineering College, Kurnool, Andhra Pradesh, India. Today we'll see the lecture on control systems. Yeah. Basics of the control systems, then method modeling, and so on. You can go as a syllabus of our college. Lectures may be continue as per our syllabus content. So what is a system? Well, first of all, what is a system? Right? A system is a collection of components so that interact with one another with the environment. This is called a system. That is a interconnection of the elements or components so that we interact with one another and the environment. This is called a system. Okay. So in control system, an interaction components forming a system configuration that will provide the desired response. That is, we want some desired input, we want some desired output. Okay, so that you will get in control systems. Okay, so this is the simple what is called block diagram. Okay, this is a process. Process may be any type. So the input is input, output. Okay, so this is the representation of the control system. This simple block diagram. Right. So what is the process here? So the process may be plant or a system under control. Okay, it may be input, output. So relations between input, output. Okay, so effect on the cause and effect of the relations of the process. Okay, so these are control systems, right? So what are the different types of control system? Okay, so mainly there are mainly two types. Okay, and maybe another open loop control system and closed loop process. And then now it is multi-variable control system also came. So previously generally are only studied in long back open loop and closed loop only, but it is a multi-variable system. Okay, so what is open loop system? So there is no feedback in this open loop system. That is, they are not taking any feedback from the output to the input, right? Not getting any feedback. Okay, so this is the called as open loop control system. Okay, so it like here you can get the desired output. Okay, for desired input. Okay, so control system already I told. So control system consists of subsystems plans assembled for purpose of obtaining the desired output with the desired performance and given specified input. Okay, so this figure shows the control systems in this simplest form. So where the input represents the desired output and any desired output. So any control system consists of essential elements, three essential elements. What is called as namely input, output, and system. We call as a process here. So the input is maybe called as generally in our electrical system called excitation, right? So applied to the form of the electrical energy source. So the system is arranged or system is arrangement of the physical components. So that is called output is the actual response obtained from the system. So that is the actual response of the system, right? So for example, take the example for open loop control system. Take the elevator. Okay, we call it lift. So you want to go for 4th floor. So which button you will press in the after going to inside the lift? You press the 4th floor button. Okay, you are in ground floor. So the elevator rises the 4th floor with a speed and 4-level accuracy designed for a passenger comfort. And the push of the 4th floor button is an input, and that represents our desired output. Okay, so desired output. So here maybe the elevator can reach the 4th floor. Here maybe the input is the 4th floor. Okay, so input is exact, but output also is the 4th floor. So this is the best lift is the best example for the open loop control system, right? Then you can see here the outcome, that is closed loop system. So closed loop system is the combination of open loop with a feedback. We are taking with the feedback here. So here this is the measurement, the feedback. Okay, so here you want some desired output. For example, take the machines, electrical machines. So I want the speed as a maybe 1500 RPM. Okay, you take the motor. Okay, 15 RPM. So you are given the supply. It may be, if you take the DC motor, the DC supply. It may be take AC motor, AC supply. So if I want desired speed is the 1500. Okay. So how to get the desired speed? How to so by measuring the either tachometer or measuring by sensor, you can observe can measure the speed. So maybe 1500 RPM. Suppose I will not get the 1500 RPM. I get only 1440. So how can get the desired 1500 by only feedback? By feedback, now I can change the input excitation. The input excitation means voltage. So I can change the voltage now. Okay. So by changing the input excitation voltage or current, we can get the desired output. So we call it a closed loop. So we are using the feedback from the output to the input. So it may be feedback. Maybe there are two types. It may be negative feedback or positive feedback. There are two types are there. Okay. So these are two types of feedback. So other system is called multi-variable system. So it's called a multi-variable system, right? Now these are the I told now there are for a control system, for a closed loop control system, there are two types of feedbacks. Okay, the system. So here there are two types. One is the negative feedback. One is the positive feedback. You can observe the system here. So there is the input. Okay, now we are taking the controller, and one is the process. Okay, may be plant, then output. Then we are taking the feedback from the output to the input. Right. So here you can observe this here. So these you are taking the negative feedback. You can take here also positive. We call it positive feedback. Right. Negative feedback and positive feedback. Okay. So depends upon our plan, our requirement. It depends our opinion. It may be negative or positive feedback. Okay. Now you can observe what are the different types of there are different types of control systems. Okay. So depends upon the input, or we call as a system. So here you can observe the different types of these are linear control system. Okay, what is linear control system? So in order to understand linear control system, we should know the principle of the important properties of their what is called as a homogeneity. Homogeneity. Okay, homogeneity, right? So a system is said to be homogeneous if we multiply the input with some constant, then output will be multiplication of the same value of the constant. So that is called as a linear control system. So consider a purely resistive network. So with a constant DC source, resistive network with constant DC source. Okay. Then what is a non-linear? What is it? Right, it is called linear control. So you can observe this here. Then for a given output, the input, you are getting some response. You can observe here, right? For the process input that you can observe it is going to the origin, maybe decreasing or increasing. You can observe it is the same for you can in this figure for the 2 input you get 15 for 4 and 20. So you can go get you draw the if you join the points, you can go from origin. You can observe it may be decreasing or decreasing. You can observe this is the linear. So this is the linear characteristics of the systems, right? So this is called linear. So what is the non-linear, right? What is the non-linear? So we can simply define non-linear control system as well those systems which do not follow the principle of homogeneity. The system which do not follow the homogeneity called as a non-linear systems. Okay, so not generally the maybe all the devices, not all. Okay, you can observe the non-linearity in different types of devices. Okay, so when linear control systems are idealized but fabricated by the analysis purely for simplicity analysis design, when magnitude of the signal control system limited, so range of its may be complete. So exhibits linear control system the essential linear. Okay, right. Now another classification is the time invariant or time variant. Okay, time invariant or time variant system. So you can see these are time invariant equations. You can observe the characteristics of the do not depends upon the time. It not depends upon the time. The college not depends upon the time. Okay, so time invariant. Okay, then time variant system. So it depends upon the time. So you can observe here, there is a time dependent. You can observe in this equation. So in this, you cannot depends upon the time. In this case, it depends on the time. So time variant, time invariant systems, right? Then lumped parameter. Then another type is the lumped parameter, distributed parameter. Lumped parameter and distributed parameter. So in this control system where the lumped parameters in the system's control system may be various active and passive elements like inductor, capacitors are assumed to be the concentrated at a point. So that's what we call as a lumped parameters of the system. Okay. So what is distributed? So same thing, if we take the parameters like inductor and capacitor, capacitor assumed to be distributed uniformly along the length. Okay, so this is called the distributed parameter of the system. Okay, these are the example of the lumped parameter and distributed parameter. Right? Then continuous and discrete data system. Okay, continuous systems or discontinuous system called as continuous systems and discontinuous systems. Okay, so there you can observe this waveform is continuous. So for a given time, this gives the some output. Okay, so it's continuous. There is no discontinuous in this case. So that is at the interval of time, there is a value of x of t at every interval time. Now you can observe in this case. So at every interval there is a discontinuous. You can observe the waveform. So this is a discrete control system. Right? Okay. So this is continuous and this is a discontinuous. Right? Then on the type. So determinist and stochastic control system, we call it deterministic. So you can observe determinist makes generally the waveforms may be in an electrical system sinusoidal waveform, or we call it some half-wave rectifier, full-wave rectifier. Okay, determinist. So that is the time interval is symmetrical. You can observe in this case. There is a triangular. You can see the 0 to some values. So it is equal. It's also equal. You can observe. So now we can observe 1 minute. Yeah. So C can also these are maybe 0 to 1 is existed, then again exist again. Okay. So this is the determinist. So the response is it may be periodical or repeatable. It may be periodical or repeatable. Okay. This is called these are determinist. Stochastic, you can observe the waveform. So the observed waveform is, you can observe the waveform. Right, so here give the pen again is down again. Okay, so this is called as a stochastic, not a symmetrical. You can observe, it's not symmetrical, it's not a periodical, it is a repeatable. Okay, both are not. So can this type be called as stochastic control systems, right? So this on at the end, you can observe the classification of the control system. You can see the control system natural. Right, then again man-made, go to the manual, then automatic, then automatically again to open loop system, closed loop system, then again open loop system may be non-linear, linear, then closed loop also may be non-linear and linear, again non-linear to time variant and time variant and time variant, then again time. So these are the in control systems. Generally, this type of classification is generally we can classify the systems, right? So what is the difference between the open loop and closed loop? So generally the can get in as a exam point of view. The exam point of view, then just given the what is the difference between open loop and closed loops here. Already you are seeing that in open loop system there is no feedback. Then you can observe in closed loop there is a feedback. It may be negative feedback or positive feedback. Then in a open loop is not kind of intelligent, that is not getting any feedback from the output to the input. Here the closed loop there is a controlling action. Okay, so there is no possibility of the undesirable system oscillation. So that is undesirable, there is no system in a open loop. In closed there is undesirable system oscillations. In electrical college hunting. Okay, so then in open loop the output will not vary for a constant input and provide the system is remain unaltered, but maybe in closed loop we can vary the input. So when we can vary the input for a desired output. Okay, so depending on the feedback there is a change in input in a closed loop system. Then coming to the open loop system, the output variation due to variation in the parameters of the system is greater. Then coming to the closed loop, the system output variation due to variation of the parameters. The various parameters can maybe in a feedback system. Okay, so in open loop there is no error detection. Then you come to the closed loop, there is a error detection. Then here come to the open loop, the small bandwidth. Then there is a large bandwidth in closed loop. Then it is a more stable compared to the open loop closed system. The open loop is more stable compared to the closed loop system. Okay, and also less, now come to the closed loop is less stable compared to the open loop. Okay, and open loop is not affected by the nonlinears, and maybe the closed loop is affected by the nonlinears. Then is the very sensitive in nature. Open loop is very sensitive in nature, whereas the closed loop is not a sensitive compared to the open loop. Okay, in the as a design aspect of view, the open system is simple design, the closed loop is a complex design. Okay, and as a cost of point of view, the open loop is very less compared to the open loop system. Is costly. Open loop, that is the closed loop system is very costly. The open loop is very less in a cost compared to the closed loop. So these are the difference between the open loop and closed loop systems, right? Then coming to the types of feedback, I don't know, there are two feedbacks. One is called as a negative feedback, one is called as a positive feedback. Okay, so depends upon our requirement, it may be feedback, may be positive or negative. Generally you are using, generally most of the systems you are using negative feedback, not going for positive feedback. Okay, so in a positive feedback, the college the feedback adds the reference input. The college adds the reference, that is the input may increase. Okay. In negative feedback, there is a difference between the output and college, that is called error. Okay. The difference between the reference input. Okay. That is called as a system output, right? So the simple closed loop control system is given. So already given in previous slides. So here we are using the negative feedback, negative feedback, right? So controller, plant, okay, then output. So from output we are taking the feedback to the input. Okay, so this output may be any time. Then error. So what is error detection? The difference between the output and the input called as error detection. So here you can get the error signal through the array controller. Then you can get the from controller you get the activity signal. Then activity will give the more input to the plant. Then again you will get the desired input. So these are the block diagram of the closed loop control system with the negative feedback. Right? Then what is called as generally you call it in a transfer function control system. This is the most what you call it a transfer function in a control system, like efficiency in a missions. Okay, if we want to discuss the missions, what is the efficiency? What is the efficiency? Similarly, you can get the most that is called word that is called transfer function. Transfer function. What is the transfer function? So transfer function is the ratio of the Laplace transform of the output by Laplace transform of the input. Okay, assume that the initial conditions are 0. So this is more important here. The initial conditions is are more role in a control system. So you take the plant, any plant. So what input is the E of t, the input. Okay, the output is Y of t. So Laplace transform of the, so here the L is Laplace transform. So Laplace transform the output, Laplace input. So you are taking generally the variables are taking in small letters. Okay, U of t, Y of t. Don't take the Laplace transform E of s, Y of s. So here the transfer function is not taking Laplace transform the output by Laplace transform the input. Okay, G of s is equal to Y of s by E of s. So this is the transfer function of the open loop plant, right? Now these are the basics of the introduction of the control systems, right?